Chapter 22, Problem 19. A rectangular loop of wire with sides 0.2 and 0.35 meters lies in a plane perpendicular to a constant magnetic field. See Part A of the drawing. The magnetic field has a magnitude of 0.65 Tesla and is directed parallel to the normal of the loop's surface. In a time of 0.18 seconds, one half of the loop is then folded back onto the other half, as indicated in Part B of the drawing. Determine the magnitude of the average EMF induced in the loop. So, since I don't have enough space for this whole problem to be on the screen, I'll just have to erase it. So, they want to know the average EMF induced in the loop. I'll just put the picture up so you could see the picture at least. So this is the picture that is shown in the problem. Now they want you to find the magnitude of the EMF induced in the loop. And that can be found using Faraday's law of electromagnetic induction. So EMF is denoted by this. And the equation is negative N. The magnetic flux. The change in the magnetic flux. Over the change in time. And in the problem, they give you a couple pieces of information. So they give you area. And I calculated the area, which is 0.2 meters times 0.35 meters. And the area for this would be 0.07 meters squared. They also gave you the magnitude of the magnetic field, B, which is 0.65 Tesla. They give you the time, T, 0.18 seconds. And lastly, they give you N, and N stands for the number of loops, and that is one loop. So back to the equation for Faraday's law. So they give you so the equation is the EMF is equal to negative N, number of loops, times the change in the magnetic flux over the change in time. So now you have to simplify this equation even more. So you know that the magnetic flux is B times A times cosine of the angle. Cosine of the magnetic flux. So BA negative N times BA cosine minus the same thing, except it will be A naught, or at least, yeah, A naught. Over a change in time. Now this makes things a little bit easier only because they already give you the area. They give you the area, the magnitude of the magnetic field, the time, and the number of loops. So now it's pretty much time to plug in. So you know the number of loops is equal to 1. So it'll be negative 1 times B. B, the magnetic field, 0.65 Tesla, times, this would be the A in this part would be the final area, and the final area is 0 meters squared. The initial area is the one that we calculated, which is 0.07 meters squared. Also, the angle normal to the force is 0 degrees, minus the same thing, except only the area changes. 65 Tesla times 0.07 times cosine 0 degrees, all over change in time. And we can just actually put that in. The change in time is 0.18 seconds. And now you just pretty much plug in what you have, and the answer that you'll end up getting is the average EMF is equal to 0.25 volts. And that's the answer to the problem.